Let's talk about Model 2 together. So, in this scenario, we're told that we have some parts. Essentially, we have plenty of parts to make the car, except for we only have 5 engines and 12 cylinders. So, let's look at our car parts. Looks like a cylinder are these three little blocks here. So, that means that we have to have three of those for every car. And then our engine is right here. We just need one of those for every car. So let's think about our engines. If I have 5 engines, then I can make 5 cars. If I have 12 cylinders and I have to have three for every car, right? Then that means I can only make 4 cars. Okay, so which one of these parts is actually limiting my number of cars I can make or limiting production? That would be the cylinders. So the way that I typically think about it is sometimes I'll put it in a chart or kind of write down what I know. So I know that I had 5 and 12. I knew what I needed per car. So then I could think, okay, well, how many cars can be built? I have 5, I only need one, so I can make 5 cars. If I have 12, I need 3 per car. I can make 4 cars. Okay, so when we're thinking about kind of what we can make or what we can produce from our reaction, we're calling that our theoretical yield. So this is a term that you need to know. You have the definition right here. A theoretical yield is just the maximum number of products produced in a chemical reaction. So what did I calculate? Based on what I know, what can I make? So in this example, our theoretical yield is 4 cars. Okay, so we can also apply our limiting reactant information to this scenario. Which one of these car parts is limiting the number of cars we can make, right? Which one is running out first? So that would be our cylinders, right? Because we could only make 4 cars, we ran out before we could make 5. Our cylinders is our limiting reactant. So when we think of the term limiting reactant, it's just the one, whatever our ingredient, our reactant is, that is limiting the product that we can make. We're running out of it first, okay? So let's look at this image here and let's see if we can use these particle drawings to help us identify the limiting reactant. So in this case, I have nitrogen, right, that's being added to hydrogen, and we're trying to make this molecule NH3. This is actually ammonia, like what you find in Windex and other cleaning products. So I'm just going to take this little molecule right here, right? And I know I have to split it up because my ammonia molecule only has 1 nitrogen, but it needs 3 hydrogens. So let's take these hydrogens right here. We're going to put them there. These hydrogens, I'll put one there and one there. And then these hydrogens, one there and one there. Okay, so I've used, let's go ahead and mark that out, one of my nitrogen molecules and then 3 of my hydrogen molecules in order to make 2 ammonia. But I still have ingredients left, so let's see what else I can make. So let's take another one of these. I'm just going to split it up again, just like I did. And I'm going to take some more hydrogen. So there's 2, there's 2. Well, that didn't look good. And then there's 2. Okay, so I have 2, 4, 6. So I have all my hydrogens there. And now if I look, I've run out of hydrogen. So I can no longer make any more of my product because I've run out of hydrogen. So that's going to make hydrogen my limiting reactant, right? But I have some nitrogen left over, right? So that makes hydrogen my excess reactant. So your excess reactant is just whichever one you had extra of, okay? So if I look here, I'm going to erase some of that. We'll kind of put our invisible one there. These numbers in front, these coefficients, these are helpful because they're essentially letting me know how much I need in order to make my product. So if we think back, okay, to these first 2 little ammonia molecules, NH3 molecules that I made, right? Remember, I used 1 nitrogen, and then I used 3 hydrogens, right? So that matches what we know. 1 nitrogen, 3 hydrogen makes 2 NH3s. Okay, and then I did the same thing again. I took 1 nitrogen, 3 hydrogens to make 2 ammonia. So these coefficients here, we call this a ratio. Specifically, we call it a mole ratio because remember, the mole is just a way to count how many of something we have, so how many molecules we have. So these numbers or these coefficients, right, these are always going to tell us what we need. So just like in the s'mores, right, we needed 2 graham crackers for every 1 marshmallow and 1 piece of chocolate to make 1 s'more, right? That's what these coefficients are telling us about our ammonia molecules, okay? And then if I wanted to get really precise, we know that matter can't be created or destroyed. So over here on my product side, or what we, after the reaction has taken place, we still have these 2 little nitrogen molecules just kind of hanging out, right? Hanging around. Because remember, they're the extras. They're extra or excess. They didn't disappear though. They're just not really involved in the reaction. So they're just kind of hanging around there, kind of as leftovers after the reaction.